Hello friends, in today's question, a small block of mass 1 kg is released from rest at the top of the rough track. The track is circular arc of radius 40 meter. The block slides along the track without toppling and a frictional force acts on it in the direction opposite to instantaneous velocity. The work done in overcoming the friction up to the point Q, as shown in the figure, is 150 joules. Take the acceleration of due to gravity g as 10 meter per second square. So we have to find out two things. First, we have to find out the speed of the block when it reaches the point Q, and in second, we have to find out the magnitude of the normal reaction that acts on the block at point Q. So the block is released from this point and it travels along this semicircular arc or circular arc. The portion with which it travels from, let us suppose this point is called as Q prime. From Q prime to Q, there is a frictional force, and the work done in overcoming this frictional force is given as 150 joules. So everything we have to find out what will be the speed at point Q and normal reaction at point Q. So let us solve it. We say, suppose the block is released from point Q prime and it reaches point Q after falling through a height of h. So it means from Q prime to Q, it falls through the height h. So this is our h. And because of the fall, what is going to happen? It is going to lose its some potential energy. Therefore, it also loses its potential energy. And we assume let v is the velocity at point Q. So we can say if v is the velocity at point Q, then we can write the equation that potential energy minus work done against the friction will be giving us kinetic energy. So this entire thing is with respect to point Q. So there is a loss of potential energy minus the work done against the, you can say, the friction from Q prime to Q. This will be equal to kinetic energy. So potential energy is given as mgh minus work done in the friction, the value is already given, that is 150. So this is equal to kinetic, that is half m v square. Now we can find out value of h, because if this is our Q point, this is our P point, and this is our Q prime. So height h, we can say this angle is 30. This is the radius of the circular arc. So from here we can say that our h will be equal to r sine of 30, which is r by 2, or we can say that our h will be coming as 20 meters. Now we substitute value of h, and we can calculate the value of the velocity. So mass is 1 kg, g is 10, h is 20 minus 150 is equal to half 1 v square, and if we solve it, we get v is equal to 10 meter per second. So this is the velocity at point Q. This is the velocity at point Q. Therefore, we can say option B is, B is correct. You can say option B is the correct option. Next, for B part, we are supposed to find out the normal reaction at point Q. Therefore, let us draw, this is our point Q, and we have point P. The downward direction we are going to have mg, and this angle is given as 30, so we can say this angle will be over 60. It can do mg can vary in two components. This will be over mg cos of 60, and this will be over mg sine of 60, and there will normal n. As the ball is moving in a, you can say, circular arc, there will be a centripetal force. We can write that equation that at point Q, the centripetal force will be, we have mg cos theta minus, n minus mg cos theta, n minus mg cos of 60 is equal to mb square upon r, where r is this radius. Therefore, we can put the value of, we can write n will be equal to mg cos of 60 plus mp square upon r. We substitute the values. M is given as 1, g is over 10, cos 60 will be coming as 1 by 2, mass is 1, velocity we already found out is 10, and radius is given as 40. So this will be giving us n is equal to 5 plus 2.5, or we can say that normal is equal to 7.5 newtons. You can say this is the normal reaction at point Q. So we have that option number A is the correct option. So you can say option A is correct. Small a. This completes the question. Thank you.